Hi everyone. In this session we will see block diagram of 8086 microprocessor or architecture of 8086 microprocessor. In this session we will see brief introduction of each and individual part which is in 8086 microprocessor. In next lessons we will see each and every individual block with clear explanation of 8086 microprocessor. In First of all, in 8086 microprocessor, it contains registers. Registers are used to store the data. Here, it contains 4 general purpose registers and 4 special purpose registers. Here again, these 4 general purpose registers are divided into 2 8-bit registers. Here, AX, BX, CX, DX are called general purpose registers, which are 16-bit registers. Again, these 16-bit registers are divided into 2 8-bit registers. Those are AH, AL, BH, BL, CH, CL, DH, DL. Here, total 8 general purpose registers and 4 special purpose registers. Here, AX is nothing but a accumulator register. BX is nothing but a base register. CX is nothing but a code register. And DX is nothing but a data register. These are the registers. Here, CX is nothing but a count register. Here, these 4 16-bit registers are divided into 2 8-bit registers. And again, we have 4 special purpose registers. Here, these are pointer registers and these two are index registers. These are pointer registers and these two are index register. Here, SP is nothing but a stack pointer, BP is nothing but a base pointer, destination index, source index. These are the pointer registers and these are the index registers. These 4 are special purpose registers and these are these general purpose registers. AX, BX, CX, DX is nothing but a 16-bit register which is divided into 2 8-bit registers AH, AL, BH, BL, CH, CL, DH, DL. Here AX is nothing but a accumulator register, BX is nothing but a base register, CX is nothing but a count register and DX is nothing but a data register. Here AL is nothing but a lower byte, AH is nothing but a higher byte. We all know that group of 8 bits is nothing but a byte. 8 bits is called byte and 4 bits is called nibble. Here a lower byte. This is lower byte and this is higher byte. So this is about registers. And now another one is temporary registers. Here temporary registers are used to store the data temporarily for performing arithmetic and logical operations. Here ALU. ALU is nothing but a arithmetic and logical unit. Here arithmetic and logical unit which is used to perform arithmetic and logical operations. Here we have to see that flag registers. Here flag registers are used to indicate the status of the result after performing arithmetic and logical operations. For example, if you perform 2 8-bit addition, then after performing addition of 2 8-bit numbers, then if we get any carry in the result of the operation, then by using flag registers, in flag register carry flag is also there. By using that carry flag register, it is set to 1 whenever if we produce carry in the output of the arithmetic operation, then the carry flag is set to 1, otherwise it's set to 0. That means here flag registers are used to indicate the status of the result of after performing arithmetic and logical operations. For if we perform operations to signed numbers are called as negative numbers, then sign flag is set to 1, otherwise it's set to 0. So this is the purpose of flag registers, ALU and temporary registers. And here ALU data bus. Here ALU data bus is nothing but a 16-bit 16-bit. See the 16-bit ALU data bus. Bus is used to carry the information. Information is nothing but a data and address to the registers and to the specified locations. And here internal control system. Here internal control system which is used to control the system internally. And here we have address generation. Here address generation is easy. It is used to generate the address. And this is address bus. It is a 20-bit address bus. And this is the data bus which is 16-bit data bus. By using data bus, data is transferring, and this is address bus which is 20-bit, and this is a 16-bit data bus, and it contains stack registers. These are stack registers. These are code segment register. DS is nothing but a data segment register. SS is nothing but a stack segment register, extra segment register, and instruction pointer. These are the stack register, and this is the instruction pointer. And internal communication registers. It is also contains some internal registers for communication purpose. And this is about, and another one is bus control logic. Here bus control logic is also used to control the bus, and this is about 8086 bus. And instruction queue. Here instruction queue is nothing but it has 6-byte instruction queue. 1 2 3 4 5 6 is nothing but instructions. Here instruction queue is also important concept in 8086 microprocessor. Here instruction queue used to increase the speed of 8086 microprocessor. And this is about brief introduction about 8086 architecture and our block diagram. In next and another one is, we already discussed about in the features of 8086 microprocessor. 8086 developed by Intel was the first 16-bit microprocessor, and it is designed by using HMOS technology. In this now only we saw that architecture of 8086 microprocessor, it contains instruction queues, stack registers and general purpose registers, and extra segment, code segment, special purpose registers, address bus, data bus, instruction queue. These are the parts which 8086 microprocessor internally have, and it is designed by using HMOS technology. And the complete architecture of 8086 can be divided into two parts. Here first one is bus interfacing unit. It is nothing but a BIU. And second one is execution unit, which is nothing but a EU. The first one is bus interfacing unit. Here bus interfacing unit in 8086 microprocessor is used for transfer of instructions, data and address to the specified unit or execution unit through the system bus. Here bus interfacing unit in response to the, it is used for transfer of instructions, data and address to the execution unit through the with the help of system bus. And the bus interfacing unit is responsible for all memory access and input output access. In other words, BIU communicates with device outside the microprocessor. Here bus interfacing unit is used to for transfer of instructions, data and address to the execution unit. And another one is the bus interfacing unit is also responsible for memory access, input output access. That is like if you connect any external device to the 8086 microprocessor, then with the help of bus interfacing unit it can access, and it is used for memory access, input output port access. So in this way the bus interfacing unit is used to, this is the one unit in 8086 microprocessor architecture, and it is BIU communicates with devices outside the microprocessor. This is about bus interfacing unit. And next one is execution unit. Here the execution unit is responsible for the instructions fetched by the BIU. Here BIU is used to fetch the instructions, and after that The execution unit is responsible for the instruction fetched by the BIU. BIU is used to fetch the instructions, and after that instructions, the execution unit is used to execute those fetched instructions, and it performs four kindly operations. Here execution unit performs four operations. Those are fetch, decode, execute and write operations. First it will fetch the instruction, then it will decode the instruction, after that execute the instruction, after it will write the instruction. These are the operations that performed by the execution unit. And another one is here the four operations will performed by the AU in some defined number of clock cycles. Here these operations are performed by some defined clock cycles, and for some defined clock cycles by execution unit performs these operations, and it contains arithmetic logic unit, status and control flags. And execution unit is also contains arithmetic logic units and status and control flags, general purpose registers and special purpose registers. This is about execution unit. Execution unit, it has arithmetic and logical unit, status and control flags, general purpose registers and special purpose registers. By using these all, it will perform fetch, decode and execute and write operations of the instructions. And here the BLU in bus interfacing unit, it will transfer instructions, data and address by using through system bus. And bus interfacing unit is also responsible for memory access, input output port access. In other words, BAU communicates the devices outside the microprocessor. These are the two units which are very important in architecture of 8086 microprocessor. In this session, we saw about brief introduction of 8086 microprocessor architecture and what are the parts and what are the main units in 8086 microprocessor. In next session, we will see about clear explanation of each individual block in 8086 architecture, and I provide study material for this content in my description box. If you like this video, you can subscribe